Right, question 6. This is where it gets a bit different and a bit more difficult. So what it's saying is that 50 ml of 1 mole per decimeter cubed nitric acid was added to 20 ml of a 1 mole per decimeter cubed barium hydroxide solution. The temperature rose by 7.9 degrees C. Calculate the enthalpy of neutralization. And this time it says do it per mole of nitric acid reacting. So at this point you need to be thinking along the lines of stoichiometry, okay, the chemical equation and how many moles of which react with which. Assume that the density of the solution is 1 gram per centimetre cubed and that the specific heat capacity is 4.18. So the first thing to do, the easy bit, is to work out the energy change during the reaction, and it's MC delta T, and that's going to be 50 plus 20 is 70 grams times by 4.18 times by the temperature change, which was positive 7.9, and that is 2312 or 2.312 kilojoules. Right, the next bit, okay, we're going to work out the delta H is minus Q over N, but it has to be for the nitric acid, so it's N HNO3. Right, so the equation then, let's have a look at that. HNO3 plus barium hydroxide. Now that's going to produce water and salt, so we're going to form H2O. The salt's going to be barium nitrate, barium being a 2 plus, nitrate being a single minus. Switch 2. So that's it there. We then need to balance, so we're going to need 2 lots of this and we're going to need and produce 2 lots of this. Now, the question asks for us to use the number of moles of this that's reacting. So the first thing we need to do is to work out the number of moles of each, and to do that both solutions, so it's MV over 1000. So for this one it's going to be 1 times by 50 over 1000, and that equals 20 over 1000, and that equals 0.02 moles. Now, the number of moles of this one is going to be 1 times by 50 over 1000, and that's going to be equal to 0.05 moles. So that means that this one is in excess, and that this one is the limiting reagent, and normally we would use this value. However, in the question it asks for us to use the number of moles of this that's reacted. So if we now look at the stoichiometry, for every 1 mole of this we need 2 moles of this. Now we're given the limiting reagent 0.02, so for every 0.02 moles of this, then 0.04 moles of this will have reacted. Now that means that in the solution we're going to have 0.01 moles of unreacted acid left, but that's not really anything to worry about. What we do know, however, is that the number of moles of HNO3 that's reacted is equal to 0.04. So now we can go back to this and we can say that the delta H is equal to minus Q over N, which is equal to minus 2.312 divided by 0.04, and that comes out as minus 57.8 kilojoules per mole.